Hello, everyone. Thank you so much for joining us today for our webinar, Building a Smaller Toolbox, Student Ownership of Algebraic Reasoning with Story Tables with our incredible speaker, Shira Helft. We're so excited to have all of you here today. And I'm just going to go over a few quick housekeeping things before we go ahead and get our webinar started. While I do that, I would love to hear from you all in the chat. Just a couple things about maybe like where are you from? What grades do you all teach? And what made you want to join our webinar today? And while you do that, I'm actually going to pull up the chat because I would like to hear from all of you as well. And I'll drop my information in there. Oh, somebody from Romania. Very cool. International immediately. Very fun. Kentucky. Hello, Debbie from Kentucky. Love to see you. Oh, lots of Kentucky today. LA, Arizona, another Kentucky. Kentucky's showing up and showing out today. Very fun. If you're not from Kentucky, it's okay. You can lie in the chat and say if you're Kentucky if you want to fit in. I now am also from Kentucky. But it's been about a minute, so I'm just going to go ahead and get us started. Just a few helpful tips for our webinar today. If you would like to access the closed captioning, you can click the CC button in the bottom of your tray, and that will pop up subtitles for you for this webinar. If you would like to participate, we would love to hear from you. Throw some comments in the chat. Let us know what you're thinking. Let us know if you have any questions. But if you have questions for Shira that you are like so desperately need her to answer this question, please drop that into the Q&A toolbox, and then we will go ahead and save those for the end of the webinar and get to them if we have time. You should receive a certificate of attendance from Zoom a day or two after this webinar, so keep an eye out for that email from us and from Zoom, and then you will receive another email from us with the recording and a few additional resources from us. With that being said, I would love to introduce you to Shira. In addition to being a math teaching and learning enthusiast, Shira is also a writer and product lead at Amplify, and she is also the co-creator of Story Tables. In her free time, Shira loves to do cryptic crosswords as well as some puzzle games as well. So, Shira, handing things off to you. We're so excited to have you. Thank you for joining us.
Hi, I am very excited, also a little bit nervous. I was telling Ryan that this is a topic that I love, and I also haven't done a webinar in 7 years, so I hope you will be very kind to me. I am going to share my screen, and I'm also going to ask Ryan to drop in the link. We're actually going to be in an activity builder together because one of my favorite parts of learning math is doing math. And so if you are near a computer, you may want to grab one of those. It will be a little bit easier to follow along on a computer. And if you're like, that's not for me today, then we will figure out how to do it later. And I'll share this activity with folks after this. So, can I confirm that folks can see my screen and that it says building a smaller toolbox and it has my name and this cute little thing with two wrenches and amazing, fabulous. So, this talk is called Building a Smaller Toolbox. And what we're going to do is I'm going to have folks join, and I'm going to give you just a minute to join. I see 7 friends are already inside. That is very exciting. And I'm going to give you a minute to join, and then tell me how you're doing today. So just want to do a little human check-in before we get started to see like what are you bringing in with you? Are you feeling neutral? Are you feeling proud? Are you feeling joyous? Are you feeling surprised that you showed up here, that it was 1 week later than you thought it was going to be? Um, are you feeling sad, which is the way that I feel sometimes? Oh, 24, 25, 26. Let's see. How are folks feeling today? Ooh, curious. Oh, we got a neutral in there. Okay, it makes sense that lots of folks would be like, "What the heck is a story table?" And I've never heard of that thing before. What is going on with it? And so I'll give folks just a minute, but I am unsurprised to see a lot of curious, and I'm also glad that someone who is sad felt comfortable enough to share that they are feeling sad today. So I'm going to start while people are coming in and telling us how they're feeling today with some thank yous because I did not do this on my own. I am obsessed with story tables, and you'll find out why. But I did develop them with Rick Barlow, Nate Pinsky, and Taryn Pritchard when I was teaching math at Fremont High School in Sunnyvale and then also at Gateway High School in San Francisco. So I live in Brooklyn now, but my previous life and previous teaching life had me in California. I also am super grateful for the fellowships as a teacher that helped me continue to grow and build. And frankly, if you have met me in the last 12 years and I haven't talked to you about story tables, like we probably don't know each other well enough yet, and just wait, it will be coming soon. So I just want to give a huge shout out to all the folks who helped me to get to this place where I am really excited to share with you. And I'm actually going to unpace you and I'm going to sync you to me so that you can actually join in as we talk through some of these slides. So I'm going to sync you to me. So you should all be on some thank yous. And now we're going to go forward to some goals. So my hope for this time is that you learn what the heck story tables are, that we do some math. Again, that's my favorite part of being in sessions is doing a bunch of math. And then that we get to think about how the mathematical representations that we choose can affect how much students own the ideas that they're bringing in with and the power that that can bring. Yeah, and folks who are joining late, we're going to just keep putting that code in over and over again. So you can just join in and you'll be right along the way. So here's a little bit of our plan for our time together. So I'm going to talk a little bit. We're going to do a little bit of math. We're going to share out. I'm definitely looking for ideas from this chat. So I am so excited that people are already sharing their thinking. We're going to do a lot more math. And just as a heads up, this session is designed for folks who have experience with middle school, so sixth grade through eighth grade, Algebra 1 or Algebra 2 and beyond. And so you'll get to choose your playtime, how you want to spend your time. But we'll be focusing on those three grade bands. And we'll do a whole lot more math, and then we will pause and we'll reflect together about the things that we see. All right, I'm going to pause you for just a second. So I start every single session with some things that I believe. And you might be wondering why there's a mysterious sheep on the front of this slide. And actually, for folks who, some folks do and some folks don't know that there's a character in Amplify Does Most Math whose name is Shira the sheep. And what Shira the sheep does is that she really likes eating grass and really does not like water. And I am incredibly grateful that Shira the sheep was named after me. And so I feel a strong embodiment with the character of Shira the sheep, so much so that I actually have a Shira the sheep plushie doll, which we look almost exactly the same. Um, and and so there's something really powerful and beautiful about having your fame be known as a fictional character as not and not actually as a real person. But I always start every single session that I've ever given with some things that I believe. And I think that that's really important because that is what should power the work that you do, whether you are working as a teacher, whether you are working with teachers. The things that you believe about teaching and learning are the things that could and should help you make choices about the strategies that you'll use in your classroom and the things you want to explore. Because to be honest, there are so many different things that we could get better at as math teachers. So much so that you couldn't learn it in an entire lifetime. And so I use the things that I believe to help ground me in how I choose to spend my energy when I learn about what I want to use to grow. So here are some things that I believe. One, I believe that math is about making sense. And so it should be all about things being like, oh, yeah, that makes sense because, like, it should all be this set of ideas that all fit together in a way that is something where you're like, oh, yes, this is a thing that I see and I understand. And in order to do that, or that is sort of one of the big keys into having a sense of belonging. Like, I pretty firmly believe that in order to have a successful math experience, you need to feel like you belong. You need to feel like you belong in the math classroom. You need to feel like you belong in the math community that you're in. And so you need to be able to have that in order to do the creativity and exploration and making sense. Like you have to feel like you have something of value to bring to the people around you. And so, in order to do those first two things, one of the most important parts is feeling like you own the math ideas. Feeling like, oh, yeah, I have something that I created and I'm doing that other people don't do yet, and I can teach them. And that is what one of the things that gives me a sense of belonging in the math classroom. So when I think about what strategies do I want to try, what things do I want to build, what things do I want to work towards, figuring out how to get students to feel like they are owners of the math is one of the most important things. The fourth thing that I believe is that the language of algebra is a current gatekeeper. So making sense of all of those symbols is one of the things that can make a difference between students feeling like this thing makes sense, feeling like they belong, and not feeling like they belong. And there's one more, and that's this. The fifth thing that I believe is if you can, you should use a knife. So I'm gonna talk about those last two for just a second. So when I say the language of algebra is a gatekeeper, what do I mean? I think the best illustration I've ever seen of this comes from the blog Math with Bad Drawings by Ben Orlin. And this came actually as the impetus originally for creating story tables. And it was like, okay, here's an equation 7 minus the quantity x plus 5 squared. And you're just trying to find the graph's vertex. Very classic algebra 1 or algebra 2 problem. You're trying to graph this function, you're trying to know what it looks like. And that's the prompt. And this is where things get interesting. What students see and what mathematicians see are not exactly the same thing, right? What mathematicians see is this reasoned, like, oh, I'm trying to figure out how to get the biggest thing. And so I know that it's going to be some number that makes the thing in the bracket 0. So it has to be -5 so that I can get the the largest number possible. And what I found from working with my students was they were like, oh gosh, okay, positive, negative, I switch the X's, but I don't switch the Y's. Maybe I do switch the Y's. And okay, wait, maybe I switch actually the position of the X and the Y, and there's something having to do with H and something having to do with K. And maybe there's a minus somewhere. And maybe I'll just take the numbers 5 and 7 and I will do something and hope that everything works out great. And that was the experience I walked into. I remember very viscerally my first year of teaching, having that almost that exact conversation with a student who said, yeah, I took the numbers, I got too confusing, so I took the numbers and I put them somewhere and I just hoped that things worked out. And that is a thing that I have seen over and over and over again. And that is one of the goals that created story tables, which is that the language of algebra, which is so powerful for mathematicians, became so not powerful when it came to students. Like this sort of mess of symbols was really just a mess and not actually a thing that made sense. So that's principle 4. The thing that I believe, number 5, is if you can, use a knife. And this is a conversation I had probably about 10 years ago. And the student, whose name is Michael, I won't give the last name away, said, like, but I already know how to do this. Why do I need to learn it this weird way? And I would love, before I reveal it, if anybody wants to be brave and take a guess about what is the thing that he was not super happy about learning in a weird way. So a thing he thought he already knew how to do, but I was like trying to do it a different way and he was not super happy about it. Long division. Ooh, I like that one. Multiplying. Okay. See two brave folks in the room. Take derivatives. Yeah. Completing the square. Graphing form. Yeah, so many different things. And actually, so many of them are related to what I'm about to show you. So this is what he was talking about. Yeah, he was talking about the area model, right? He was like, why? I do know how to multiply things. Why would I need to use the area model? Like, why is that thing worthwhile? Why is it worthwhile to learn this sort of other way of seeing things? And so that's my question to you. Like, why, if you do teach with the area model, what are some things about it that you love? Like, why is it worth teaching students how to do various things using a tool or representation like the area model? Hmm. Yep. The algebra is coming from the visual, so a connection to visuals. Yeah, visual things make things real. You can really see all the different pieces. Yeah, why teach with the area model? You can also see the magnitude of values, right? So I have a visual representation of this thing that is x by x making a square that is, yeah, and multiple methods enable you to be more flexible. Yeah, Marty, I'm going to pull on that one too. They build on a familiar model from elementary school, right? So there's something about I can make this progression that says, oh, okay, I can take a thing that I knew about multiplication and I can get all the way through area model, which can also be any area problem, exactly. And so you can, my favorite is I like to do polynomial long division with the area model because that is actually the model that makes most sense to me. And it's because I built all the way from the thing that I learned in third grade. Yep, it offers differentiation. There's all these different things. Yep, the model, ooh, I love that phrase. The model has travel. It can be revisited in many concepts. Okay, all of this is what I mean by a knife. So a knife is simple. It's likely possibly visual. It's something that like you can see all the pieces in, but it's not too complicated to explain. It's versatile. The model has travel. Definitely gonna be my favorite phrase this year. So you can use it for lots of different things. It's not a melon baller or an avocado pitter where you just can do one thing. It's really good at that one thing, but a knife is powerful because you can do lots of different things with it. It's also kind of hard to forget how to use. I heard someone saw someone in the chat say something about how like if you kind of forgot how to multiply binomials, you could just like go back and think about the area model. Like it's once you know, oh, I just make a rectangle, I know how to fill the pieces in and I can do that both going forwards and going backwards. And then the power is in how you use it. So a knife is a really powerful tool. And the cool part about a knife is that it can do a whole lot of different stuff if you know how to wield it. And to me, that fourth one is going to connect to the idea of student ownership that we're going to talk about later, because there's a lot of power in how you use the individual things. And so before we get to doing some math, I want to invite you, and I'm going to just take 30 seconds of awkward silence. I'd like to invite you to just think about some things that you believe about teaching and learning. You don't have to have them on a pretty slide, but like, what are the things that are really important to you or the teachers that you work with? And how might that be impacted? And I'm going to ask you to sort of hold that in the back of your brain as we do all the math for the rest of the session to see, okay, how does this tool fit or not fit with the things I believe? How does it do something that matches a thing that I personally care about or the teachers I support care about or not? The awkward 30 seconds begins. All right, I didn't count exactly. I'm going to unpause you because we have a puzzle to do, and it would be so fun to just do some math. So I'm going to set a timer for maybe 3 minutes and go ahead and try out a puzzle. puzzle, I'm just going to have you think about what you notice and wonder about it. You don't have to share anything yet. I'm also super curious what order you did things in, but that's a conversation for a different day. I can actually see all the different things as they get filled out, which is very fun. So if you finish the puzzle, you can actually go on to screen 14 if you'd like. So take a look. Yep. Whoa. So you mean share the screen where I can see the dashboard, where I can see all of your work? Let me go ahead and do that real quick. And then I'll come back to this. Yep. So, I will share this tab for just a second. And I can, if I want, see all of the individual responses. So I can see all of the different students and all the cool things they're doing. So I can open up this student. I love the word square here. I can see, I can open a different student and see the thing they're doing. And see the student is partly in the middle of their thinking. And it looks like, oh, what's cool is it looks like this student actually started with the first two columns. So they're actually working down the puzzle. And I know when I did it with a friend over the weekend that they actually worked across. So they worked across each row as opposed to down the columns, which is kind of cool. All right, I see lots of folks have made their way to screen 14, and I'm gonna stop sharing this responses so that I can sketch on things. I guess I can do that here too. So, okay, here is my question. I will pause the background music, which maybe only I could hear. Maybe I'm the only person who could hear those nice chill vibes in the background. But okay, on the left is what many students, and by students I mean you all, what many folks wrote for the story table, your first story table, congratulations, for the equation 3 times x minus 5 squared minus 7. And then here on the right is a different story table for a different function. Thank you, Kimberly. And what I am curious about is, what do you notice and what do you wonder? And this is a thing that I would love folks to share in the chat. So take a look, compare, contrast. What do you notice? What do you wonder? Ooh, the last 3 columns of the table are symmetric. So if I have my sketch tool saying that there's sort of a symmetry here, and it's not just in the last column, but it's also in the second to last and the third to last column. Ooh, similarities in certain cells for both tables. I'm curious, did anyone else see what Sarah sees? That there's some numbers that actually look like they're the same in both tables. Yes, okay, can anybody share some numbers that seem, same column, second column is the same for both? Interesting. So if I look at this second column, well, maybe minus the header. So take that off. But these numbers, this -2, -1, 0, 1, 2, are the same on both the second columns. Let's see. I wonder if this pattern holds with different quadratic equations. Oh, interesting. The same column. Oh, and the third column. Okay, so maybe I'll get a different color for the third column. That's blue, but they're the same. And someone is sort of wondering if I changed the 3 in this first equation, if that 3 was actually a 2, if then the fourth columns would also be the same. That's an interesting thing to wonder. Or if I change this to a 3, if those two sort of multipliers were the same. I also want to call out something from earlier, that someone noticed that the bottom arrows are kind of inverses of the ones at the top. So you have a -5 in the left to right direction, and you have a +5 in the right to left direction. Any other things folks noticed or wondered? All right, I'm gonna get out of here so that I can unpaste you. Ooh, fun. All the X values are different in those two things. And I am gonna sync you to me and pause you. Very sorry. So I'd like to interrupt all of this math talk for a very brief story. So here's the very brief story. Oh no, my story. Oh, I'm doing the teacher tab so you can see. My reveal is gone. Very sad. So I'm going to tell my story again because it makes me really happy. Once upon a time, there were 4 ninjas living in the woods. They lived happily ever after. That is the kind of story that I think a regular XY table is telling, right? I give you the beginning of the story, and I give you the end, and you kind of have to figure out somewhere else all of the stuff that comes in the middle. And so what is a story table? You've already explored 2 of them. It's just a way to tell the whole story inside of the table. So every part of the story gets its own column. And that was like a cool idea. Like, okay, I'm spreading out. I can see student thinking. One of the things I believe in that has been on a previous version of this slide show is that, like, I really want to see what students are thinking. And so the story table, that's when you see all the kinds of things that students are thinking. But it turned out the story table was way more powerful than I thought it was. Because one of the cool things is that if I stretch it out so that I can see every single part of the story, I can start at the beginning, tell the story the way I used to. Here's my X value. I want to figure out, okay, how do I get to the end? That's the way what you're used to thinking about math with tables. But I can also tell the story backwards. So I can start at the end of the story and figure out, okay, I can use those inverse operations that someone noticed. What was the beginning? What was the thing that I had to start with to end up at this part of the story? And my favorite is that you can actually start in the middle. And that's what some folks notice. Some folks notice, hey, there are some columns that are the same in these different tables. I love starting in the middle of the story and trying to figure out what are the X values and Y values I would need so that this quadratic moment, like this parabola, exists the way it does. And that's it. That's my talking at you. That's the me talking at you portion of this talk. I want to give you tons of playtime because actually exploring and playing with these story tables is the way to do this. Now, I will tell you, I have never done this talk virtually without people being able to talk to each other. And I believe that conversation is a natural way humans think together. So please feel free to use the chat to say things like, what the heck is going on screen 24? Or like screen 31, I got a weird number. I will play the chill vibes, and I'm also going to pop up and pull up different pieces of interesting student work and talk about them periodically. But we're gonna take a really solid 15 minutes of playtime. And I know that you are incredibly busy humans. I'm going to invite you to actually play during this time. So to actually sit and do some fun math together with the screen. And you can see middle school. So that's really like 6th through 8th ish. Algebra 1 is Algebra 1, and then Algebra 2 and onward. So depending on which area you'd like to focus, feel free to choose the screens that feel best to you. I'm going to unpause you. I'm going to sync you. I'm going to unsync you, so now you can go play. I am going to pace you through just these sections so that we don't get too far ahead of ourselves. But I'm going to pace you from 23 all the way to 42. I see lots of folks in the middle school space. Yeah, I've got kind of a nice mix between people who are working on the middle school side and people who are working on the Algebra 1. And then a couple folks who have gone to the Algebra 2 part, which is actually, I designed these originally for Algebra 2, my Algebra 2 classroom, which had a lot of Algebra 1 ideas in it. And so those are some of the things I get really excited about. You can join the playtime by joining the class code, which Faith just popped in the chat. And it should bring you to screen 21, and then you can go from there. Let's take a look at some folks' thinking here. Yep, Elise, that is exactly how I do it. So Elise asked the question of like, would I start with a story table at the beginning and then gradually release students are making their own? Yeah, I also sometimes, especially for students with disabilities or with learning differences, will just have templates, like pieces of paper templates around that have like a story table with 3 columns and a story table with 4 columns, and then students can just fill them in however they'd like. But yeah, you'll see this is a gradual release for teachers. Obviously, if I were gradually releasing for students, oh, sure, I can definitely do that, Ryan. I can also make it way quieter. I will mute the music. Yeah, so when I give, I often will have story table templates that are just blank templates that have pieces in them, and this is a gradual release. Oh, yeah, so you can type in /div, and that'll get you the division sign. I know. You keep getting a funny fraction bar. You can also write it in text. That's fine too. Ooh, all right. I'm going to go to 25. So yeah, that's one of my favorite things. Oh, Sarah, you and I are on the same page. So one of my favorite things about using story tables for some of the middle school work is that it gets students thinking about transformations even before they do transformations of functions, which they'll do in high school. So similar to how the area model starts with elementary school, where you're building up area and then you add variables in later, if you're thinking about a linear equation and you have the 5x column and you have the -4 column, you can see that all of the y values are shifting -4, even though we haven't sort of talked about this idea of a vertical shift that you're going to get when you get to Algebra 1 or Algebra 2. I also secretly like that Um, One of the biggest things that I found really challenging for students in eighth grade and Algebra 1 when we were writing linear equations is that you would see the +5. So actually, maybe I'll grab some student work on this page and we can take a look at it. So if I look at some student work on this one, so if I am looking at some student work on this one, one of the things, Joseph, I'll get to your question in a second. One of the things that I used to really struggle with is that you see an adding by 5 happening in the linear equation, and students would say, of course, that means that my equation should be x plus 5. And so it's really hard to see where the multiplying by 5 happens because it's hidden. It's right in that middle step that the multiplying by 5 happens. And so when I make a story table, I can see, oh, it's actually the number times 5. That's where that multiplying happens. And I do see the growing by 5 happening in the third column, but I also see that growing by 5 happening in the second column. And that's really where the 5 lives. And so that has been a really helpful way when I'm talking with students about how I see linear functions grow. Joseph, I would not give this set of slides to a middle school student. This is really designed for teachers. I would say that this actually, because students are using patterns, they stop doing individual calculations nearly as much, and so it doesn't take as much time as you think. So students start to say, oh, okay, 5x minus 4, oh, this is going to go by 5s. And then they just start filling in the table with the 5s. And then maybe they're doing the subtracting 4 is something they might do more manually. But because students are starting to see all the patterns in how the tables work, I haven't found that it takes significantly more time to make a story table than to make an XY table if what they're doing is trying to graph something or make sense of how something happens. And a lot of that has to do, I'd say that the table setup takes a little bit of time, which is why, especially if you have students who struggle with the executive functioning or the motor skills, that I would give them a template so they can just fill out the parts of the table. But in terms of the actual calculation piece, I haven't found that to be a huge barrier. Okay, great. I was like, Sarah, you're just getting me. I was going to say, I would love someone else to nominate a screen that we should talk about before Sarah gets to take this one. Anyone else want to nominate a screen that is not 27 that we want to talk about while people are playing? All right, I'm going to give a minute for people to go to 27 and actually try it. 23. Okay. I'm going to give folks a minute to look at 23 and 27, and then we'll talk about them together for folks who want to talk about them. So I'm going to hang out on 23 for just a second with Jamshid Al-Kashi's work. Francisca or other folks, I'm curious what you found interesting about screen 23. I can also tell you why I put it here, which is that for me, the purpose of screen 23 and the versions of it that are in Algebra 1 and Algebra 2 are all about that language as the language of algebra as the gatekeeper. So students being able to see 3x minus 10 and 3 times the quantity x minus 10, like they can kind of see them as different, but they really weren't sure what that meant. And so I have lots of students in my experience who are like, oh, that's why they're different. The 3 is the times 3, like the ordering of the operations is different. And so when you swap the operations, I can see it differently. Yeah, and I don't have an x value until screen 24. Yeah, and screen 23, I'm just looking at the arrows and the headings and just thinking about that. That's actually something that I might do with students too, is to just say, before we actually get to any numbers, I just want to look at how these expressions are different. And so I might just say, okay, the tables are like, they don't have any numbers in them yet, but I can look at the arrows and say, oh, that is different because the way that I put that expression together is different. Let's take a look at 25 versus 26. Okay, so 25, right? Again, we have that 5x minus 4 I'm multiplying by 5, and then I'm doing that sort of shift down 4. But then if I go the other way, oh, I've got someone who's working on it right now. How fun. Let's see. Is the sign on 28 correct? Let's find out. So in 26, yeah, we see this -4 as a translation. And you can also see that -5 that's sort of going up and going down. I can see it in the way that this compares those values, right? I can see those values switch from being negative to positive. Now I'm going positive to negative as I go to the right. Okay, 28. Did I mess up? Very possibly. Let's find out. Okay, let's do this together. I'm going to do it on my own so that I don't mess with this lovely student. So let me go to the student side. Go to 28. And then let's see where I messed up. Probably was me. So, okay, one of the things that I think is super cool about, oh yeah, it is. It's 3/2, isn't it? Isn't the slope 3/2? Let's find out. So, yes, I think you are correct. So, every good teacher's got at least one mistake in there. Let's take a look. So, what is the slope actually between these 2 points? Okay, so the y values, okay, I actually like to do this on the table. So the y values decrease by 3, the x values decrease by 2. All right, let's just fix that right now. Let's cross it off. -3 halves x, and then times -3 halves. Okay, despite my calculation issue, my mind got blown when I realized that you could use a story table to solve for an equation of a line between 2 points. Like that, mind blown. Because, okay, let's say, actually, I'm going to give people a chance to think about it now that we've corrected it. So now that we've corrected it, apologies for those folks who got stuck on this without the correct slope there. But how could I use this story table, if I had the slope right, to figure out the equation of a line between 2 points? And actually, I will put this on here too, because I actually use the story table itself as my way to calculate the slope. And had I done that, I probably would have caught my own mistake. Oh, let me get out of the sketching, back to here. Get rid of that. All right, I'm gonna start thinking here because I really enjoy doing this and I haven't done it in a little bit. So, okay, if the slope is -3 halves, that means that -3 halves times 2 is -12. I think that's right. I'll check it in a minute. And then if that's 10, which is the other point it goes through, then it would be -15. And then I can ask myself, okay, what would I need to do to get from -12 to -5? And is that the same as what I would need to do to get from -15 to -8? I think that is +7. So I think the equation of this line is y equals -3 halves x +7. Someone should check my calculations there if they want. Oh, I love the agreed. Cool. Yeah, it just was super fun to think about how this was a thing where I used to have students do a side equation. I would love the, I think for this situation, we'd want to do the side calculations for sure. I think for sure the thing that was complicated for me before is I would have to do lots of backwards solving and things like that. And so, yeah, I would be curious for students who are doing more, who want to do the calculations. I think actually for me, likely, Sharon, I would probably pull up that calculator. I would probably not have done this mentally if I were with students who needed more support. I would probably say, okay, 8 times -3 halves and get that as -12. And then try to do some thinking on my calculator on the side. I could also do it as a subtraction if I just wanted to say, okay, 12, negative 12 equals blank plus negative 5. Would anyone else? Someone nominated 27. I'm going to probably do one or two more screens if there's anyone else. Either any other calculation mistakes I made or any other. Ooh, 35. All right. I bet a lot of it have not looked at 35 yet. So let's take a look at it together. 4 and 5. Yeah, so 35 is the Algebra 1 or maybe even Algebra 2 version of what we just did on 28. So in this case, I am looking for the equation of a parabola, and something that I might have noticed, and maybe you even noticed actually the very beginning of the talk, was that there's all these zeros that show up in the rows when I have the vertex or I have the inflection point of a parabola. And so I actually have a student named Michael, and his whole math career turned around when he figured out that there were the zeros. And then we called it Michael's rule for the rest of the year. And every time we put those zeros in to help us find the minimum or maximum point, we got to call it Michael's rule. And that, like, you would just see his face light up every single time we did that. And so those zeros help me out. And I can play the exact same game that I played before. Yeah, I added a plus there. You could do it as plus negative 5. You could just take my plus away and make it a minus 5. That's what I like about the ability to have editable labels. You can just ignore the thing that I wrote for you and write something totally different. But I do know, right, like there's something that I know as a person who's written a lot of equations, and my students would know too, that like most of the equations of a parabola look like I take a number and I add or subtract something, and then I square it. Or if I'm looking at other kinds of functions, I do whatever that kind of function is. And then I usually multiply by something. Sometimes that number is 1. And then I usually add or subtract something. And that's kind of the structure of all of the parabolas that I get in vertex form. And yeah, you can kind of do either way. But you use the kind of structure that we know of how some of these equations look to help. So Sharon, I would say this was the most effective tool I ever taught for students who are 2 to 4 years below grade level. This was most effective with those students because what we were doing was breaking down the language of algebra. Like what we were doing was we were starting with things like this. I certainly wouldn't do this in this order, right? There would be huge numbers of stair steps in between this. There would be tons of student-facing work in there, but we spent a lot of time with my students in Algebra 1 who were at 4th, 5th grade in terms of some of their algebraic reasoning skills. Like we spent a lot of time doing, okay, how would I plug the number in? How would I go backwards to solve? What are the inverse operations that I would go with from there? We probably wouldn't get to something like solving for an equation between 2 points with a fractional coefficient. Like that's going to be the very, very end of the work that we do. We spend a lot of time in the sort of breaking down what the actual math looks like and what the expressions look like. And what if I had 10 minus 3x? How would that be different than 3x minus 10? And so to me, that actually was a really powerful tool because it felt like students started to see these sort of mysterious symbols that were sitting in front of them as things that they could make sense of. And that, so actually, I would say that for me, it was a more powerful tool for those students than for the students who could do lots of mental math and were making a lot of the connections between all the pieces that students weren't doing it. Now is a great time to drop any questions. I actually have one question for you, and then we will go from there. So I'm actually going to exit out here. I'm going to undo my pacing. I'm going to bring you all the way to here. Am I going to restrict you to screen 3? I am. I am so sorry, friends. I'm going to sync you to me. And we're going to go to 43. Yes, right. So this is a training for teachers, Sharon. This is really about how the tool works. This is not what I would use directly with students. And so, yeah, I'm curious for folks who are on this call, and then you can also feel free to put questions in. I will actually pace you from 43 all the way through 46, because that also has a space for questions, and so I can see any questions you write. So yeah, I'm curious, how might story tables help students become the owners of ideas, right? That's the title of the talk, is about student ownership. And I'm curious how something like this might impact that. How might it help students feel like they are more the owners of ideas in front of them? I love the ideas here, right? Lots of being able to play around, helping them make sense of problems, helping build more conceptual understanding, which can then help them feel like they're the ideas. Lots of practice is needed to strengthen ownership. Right, gives them another way to show evidence. It also slows them down a little bit, which I love. And I'm going to pull up to the questions. What was the book that inspired this? Oh, good question. There was no book that inspired this. This is a book that I would like to write maybe one day. What inspired this was the things that I saw with my students. So working with students from Algebra 1 onward who had lots of different ideas about what algebra looked like. I mentioned the book at the beginning. Good question. I mentioned a few talks and webinars and fellowships that I've been a part of. So there are lots of different teachers that I worked with to create these. And maybe one day there will be a book. There is actually a book that these are a part of that I will drop in. Give me 1 second. I'll pop right back out. Math with Bad Drawings. Sorry. Thank you, Sarah. Yes, Math with Bad Drawings didn't inspire the story table, but did inspire that visualization of how people teach math. That's very true. Thank you. I do actually really like this book, which is another, there is no one way to teach math. Also, I think part of my role is not to facilitate other people's books, but I do really like this one. What is the biggest piece of advice? Start small is what I would say for a person who wanted to do it for the first time. I would pick one math concept that you think this might work well with, and then give students a story table and see what happens. So this webinar will be, will be recorded so folks can share it, and I will do my best to get the code, which was in here, out, and I will open it up after the session is over so folks can go through and do anything that they want, and so they can play around with the math if you want to bring it to a professional learning community or other group that they can go through and do and play with the math themselves as well. So my students, I did this in my classroom for many years, students really liked it because it helped them see their thinking. And I think that to me, the biggest thing, and I'll actually end on this quote because we're right about time. So this is a quote that I wrote in an article about story tables, and I think it's really true, which is that story tables are the single most powerful thing I did in my classroom to open the door to switch the narrative about who is capable of deep and useful knowledge in math. It helped unlock the deep mathematical creativity my students have always been capable of using. So it unlocked the awesome powers that students in my classroom already had. And so for that reason, there was a whole lot of, oh yeah, that was my idea. We got my idea out of this. Oh, yeah, I see that symmetrical piece. That's mine. And so to me, it was one of the most powerful tools that I used in my classroom because of the way it changed the narrative about who had powerful ideas to share. Ryan, are there any other housekeeping things that you want to end with?
Yes, Shira, there are. I'm just going to go
Okay.
ahead and share this final slideshow really quickly. I would typically do a Q&A, but it looks like you handled that with your own slides. So thank you for making my job just a little bit easier.
Yeah.
So all we do have to share now is just a few helpful like resources that for you all from Amplify. So, if you would like to explore more free and ready to use math resources, you can check out Amplify Classroom. That would be formerly known as Amplify, no, sorry, Desmos Classroom. I'm used to saying Amplify Classroom so much I can't even get Desmos Classroom out anymore. The only difference between Amplify Classroom and Desmos Classroom is we added more. So there's now science and literacy there as well. So head over to amplify.com/classroom to get more amazing math resources. If you're looking for an activity to do with your students for the last few days before winter break, consider downloading our free holiday themed K through 8 math activity. That has just a few applicable real world applications of math sprinkled throughout that activity. So head over to amplify.com/feasting on figures to access that free activity. And if you would like to access some of our popular math routines, you can head over to amplify.com/math routines, and that will have math routines straight from the Amplify Desmos math curriculum for you guys to go ahead and check out. And finally, for our last webinar of this series and of the year, you can join that webinar at amplify.com/math webinars. And we'd love to have you. With that being said, it seems like that's all we have for you all today. So I just want to say thank you all so much for joining us and taking time out of your busy schedule. And Shira, thank you so much for joining us as well. It was wonderful to have you.
I am incredibly grateful for the folks on this webinar, and I hope to see you sometime in the future.
Thanks so much. Bye.